All right, we do start the class now. So we have started a transient behavior and initial and final condition. Let us revise the things. So in case of an inductor, consider inductor. It is connected. Inductor is connected to the voltage source V, and this is the switch K, and it is the notation of the switch K. The meaning of this is when switch is operated, it closes. Before operating, it was open. After switching, it closes. All right. So what we have discussed before switching, if current through an inductor is 0, then it can be represented with an open circuit. It can be represented as, inductor is represented as, if current through an inductor initially it was 0, then its equivalent circuit is open circuit. Alright, so if it is not equals to 0, say that it is A amperes. Meaning of it is, if current through an inductor is equals to A amperes. It was the condition before switching. It is denoted as I0 minus. So it is the condition after switching. Alright, then it can be represented as an current source of a value A amperes. So that, alright, these two are initial conditions. There are two possibilities. Inductor with 0 current through it before switching can be represented open circuit after switching, because 0 amperes it is. 0 amperes can be represented as open circuit. Then same circuit before switching, because of other circuits there may be a flow of current through an inductor. Its value is the A amperes. Immediately after switching, its equivalent circuit is current source of value A amperes. Alright. So what is final conditions? If the switch K is kept on for a long period, if the switch K is kept on for a long period, so inductor energizes, means there is a flow of the current from source to the load. Here load in this case is an inductor. So current flows through an inductor for long time interval and it gets energized. Once it is completely energized, when it is completely energized, it acts as a short circuit. It is called as the final condition. And before switching, if there is some amount of current flowing through it like this, so this is the equivalent circuit for first case. These two are one and the same. So it is the initial conditions, then it's respective the final conditions. For the second case, before switching, there may be a flow of A amperes through an inductor, and switch is kept on for a long period of time, then obviously it acts as a short circuit, but this current should be shown. What is that? Along with this short circuit, I need to show this A amperes. This is what these two are the final conditions of a inductor, right? Then let us say capacitor is connected in between the switch T is equals to 0. It can be represented with the help of K or S, any alphabet. and here the capacitor is connected. Alright, assume that the capacitor is initially uncharged. If the capacitor is initially uncharged, that is Q is equals to 0, or else the voltage across capacitor is 0 volt. It is what? This is the condition before switching, T0 minus. Immediately after switching, it is represented as T0 plus. So it can be represented as a short circuit, because this 0 volt can be represented as a short circuit. Alright, then one more possibility. Same capacitor, it is charged. It is not equals to 0 here. It is previously charged with some value, A volt. Then immediately after switching, it acts as the voltage source of value A volt. If it is charged with this polarity, then immediately after switching in the region called T0 plus, it acts as the voltage source. These two are initial conditions of a capacitor. Similarly, if the switch is kept on for a long period of time across a capacitor, so it charges continuously because of the flow of the current. At some point of interval, at some time interval, capacitor is completely charged. Once capacitor is completely charged, it acts as a open circuit. So this is the equivalent circuit for this first case. It is initial conditions and it is final conditions. And one more possibility. If the capacitor is initially charged before switching with an value A volt, and it is kept for a long time interval and it reaches the steady state condition, at that time it should be represented with a open circuit. Along with this final conditions, its initial value should be shown here. These two are the final conditions of a capacitor. In case of resistor, it will be same in initial conditions as well as in final conditions. So that capacitor voltage before switching and after switching will be same. That means it doesn't support instantaneous change in voltage. It doesn't support instantaneous change in voltage. Alright. In case of inductor, current flowing through an inductor before and after switching will be same. The meaning of this is the inductor doesn't support instantaneous change in current. Alright, but in case of resistor, it supports instantaneous change in the current as well as instantaneous change in voltage. These two are not equal here. It is in case of resistor. It supports, we can observe the change in current immediately after and before switching. But that is not the case in case of current, in case of inductor and the capacitor. That is shown here in table. Before switching, after switching, these two are initial conditions. It is final condition. This is nothing but a transient behavior. So before switching, after switching, and at the final condition. So resistor is kept as it is. In this case, I is not equals to 0 by 0 plus V before switching, V after switching, they are different. So second case, inductor before switching, so it carries 0 current through it, and after switching it acts as an open circuit. For the same case, if the inductor reaches the steady state condition, that is the final condition, at that time it acts as a short circuit. That means once it is completely charged, once it is completely energized, then it acts as a short circuit. One more condition, before switching, if it carries some amount of energy, that is I naught, then immediately after switching it acts as a current source. For this condition, if inductor is completely energized, then it acts as a short circuit. Then that initial conditions, that is a current source, should be shown here. Capacitor, initially it is uncharged, it is before switching, it is uncharged. After switching it acts as a short circuit, because we do find the 0 volt. 0 volt can be represented as a short circuit here. And once the capacitor is completely charged, then it acts as a open circuit. The one more possibility, initially the capacitor is charged with some amount, some charge Q0 is available in a capacitor with this polarity. Immediately after switching it acts as a open voltage source of value Q0 by C. For the same conditions, if the capacitor is charged completely by keeping the voltage source across the capacitor and there is a flow of current and it is maintained for a long time interval, then it acts as an open circuit. Then this initial conditions is shown here. And one more point, inductor acts as a current source, capacitor acts as a voltage source. Is that clear? Can you reply? Is that okay? Alright. So we will solve a few problems based on this concept. Note down this problem. In the circuit shown, the switch K is closed at t is equals to 0 with the capacitor uncharged. Find the value of I di by dt and d square by dt square, d square I by dt square at t is equals to 0 plus. For the elements value as shown, V equals to 100 volt, R equals to 1000 ohm and C is equals to 1 microfarad. This is a simple circuit. They have given voltage as 100 volt, so resistor as 1K, then capacitor as 1 microfarad. And see here, one thing is clearly mentioned. Capacitor is uncharged previously before switching. Okay, first write down the status of this. Because of this arrow, at t is equals to 0, when switch is operated, when switch is operated, when switch is operated, switch is closed here. All right. So that before switching is that t is equals to 0 minus. When switch is not operated, when switch is not operated, before switching the switch was open. This is what T0 plus condition, it is what T0 minus condition. Before switching it is called as T0 minus. When T0 minus, switch was open. When switch is operated, it is considered as a T0 plus. At that condition, switch is closed. Alright? Okay. Now, you can see here, capacitor is uncharged previously. Is that nothing but before switching, V0 minus, that is the capacitor voltage, that is equals to 0 volt. Is that okay? Capacitor is uncharged. The switch K is closed at T is equals to 0 with capacitor is uncharged. Before switching, the capacitor was uncharged. So, I can write VC 0 minus equals to 0 volt and I can write VC 0 plus because you can write the reason here because capacitor doesn't support instantaneous voltage across it. It is already discussed. Alright? Next thing is, when switch was open, can I call this as I0 minus? When switch was open, there is no closed circuit, then I can write this as current through the circuit is 0 amperes. Before switching, this K was open. See here, this K was open. If it is open, there is no flow of the current because we don't find any closed circuit there. Because of switch is open, we don't find any closed circuit. So is this the circuit? Switch was open, inductor, and it is capacitor. It is what? Switch K. It was open. So do you find current? It is equals to 0 amperes because no closed circuit. So that I0 minus equals to 0 amperes. Now, but it is not equals to I0 plus because we don't find any inductor here. I0 plus equals to I0 minus. It is in case of only inductor. So that I0 minus equals to 0 amperes, but it is not equals to I0 plus. Alright. Next, I will write equivalent circuit at T is equals to 0 plus. Equivalent circuit at T is equals to 0 plus. At T is equals to 0 plus, switch K is closed. Resistor should be written as it is. Inductor should be written with its equivalent circuit, that is shorted. So that is we discussed. When capacitor carries 0, when it is uncharged, you can see here, I have applied this condition. Here. So this is the capacitor, and it should be replaced by short circuit immediately after switching. That is done here. That is replaced here. Now, what is this current? This current is called as I0 plus. So I0 plus equals to voltage divided by resistor. Voltage in this case it is 100 divided by resistor is 1000, that is equals to 0.1 amperes. Then you can see here I0 minus equals to 0 amperes, I0 plus equals to 0.1 amperes. That's why I have said I0 minus is not equals to I0 plus because we don't find any inductor here. But it is possible. V0 minus equals to V0 plus equals to it is 0 volt because it is the property of a capacitor. Alright. Now, let us apply KVL to the given circuit. For this given circuit, let us apply KVL. Voltage V equals to voltage across resistor plus voltage across capacitor. So that is equals to I of t into R plus, what is capacitor current? Capacitor current equals to C into dV by dt. Now from this, can I obtain VC? That is equals to 1 by C into integration of IC. So can I replace this VC by this equation? This VC equals to 1 by C into integration of I of t. Call this as equation number 1. Done here. We have calculated the first value here. This is I. We have calculated the first value. I at t is equals to 0 plus, that is calculated here. I at t is equals to 0 plus, it is what, 0.21 amperes. Alright. Next, di by dt, that is to be calculated here. Di by dt. So that what I will do? I will differentiate equation number 1. What will get? Differentiation of V is what? dV by dt of V, that is equals to R is constant, d by dt of I of t plus 1 by C, then integration and differentiation they do cancel. So that I will write this as I of t. Call this as equation number 2. Alright. So d by dt of V, do you say that d by differentiation of voltage, what is that voltage? It is 100. Differentiation of constant is what here? It is 0. That is equals to d by dt of I of t plus I of t divided by C. In this case, replace t by 0 plus. Wherever you do find a t, replace it by a 0 plus. That is equals to 0 equals to R into d by dt of I of 0 plus divided by C. Then do you simplify this? So what is I of 0 plus? It is calculated as 0.1 divided by C. So that d by dt of I of 0 plus equals to minus I of 0 plus divided by C into R. Simplify this. So I of 0 plus is what? 0.1 divided by C is what here? C is 1 micro into 1K, that is equals to, is that minus 100 amperes per second? Is that right? Can you tell me what is this value? 0.1 divided by 1 micro into 1K, it is 1 milli. So 1 milli if it comes there, 1K. So 0.1 into K is minus 100 amperes. So unit is what here? Amperes per second, because here it is d by dt. Is that okay? It is simple thing here. 1 micro into 1K, it will be 1 milli. 1 divided by 1 milli is 1K. 1K into 0.1 is 100. So that minus 100. Unit is, obviously it is current, it is amperes, but it is differentiated. So that amperes per second. Alright? Good. Minus 100 divided by, minus 100 amperes per second. Alright. So that it is calculated here. It is calculated. Next thing is, so you can say here it is calculated. Next is getting the value of current at t is equals to 0 plus by double differentiating it. Alright. Now let us differentiate equation number 2 once again. What will get? Differentiation of d square by dt square of V, that is equals to R is constant here, it is kept as it is. Then differentiation of this thing is d square by dt square of I of t plus 1 by c is as it is. Then differentiation of I of t, it is what d by dt of I of t. Call this as equation number 3. Alright. So again double differentiation of constant, it is 0 r d square by dt square of I of t plus 1 by c d by dt of I of t. Now in this equation replace t by 0 plus, that is equals to r into d square by dt square of r of I of 0 plus 1 by c d by dt of 0 plus. Do simplify. 0 equals to, okay, I will do d square by dt square of I0 plus equals to minus 1 by c into r into d by dt of I0 plus minus 1 divided by, the value of c is 1 micro into r value is 1k into what is d by dt of I of 0 plus, it is calculated here. It is what? Minus 100. So minus into minus, it is plus. It is 1000 divided by 1 milli. So what is this answer? Tell me the final value of d square by dt square of I0 plus. Tell me the final value. It is what? Unit is amperes per second square. Tell me the value. Here simply I have differentiated equation number 2. Equation number 2 is this one. So differentiation of this is d square by dt square of v, r is constant. So differentiation of this is d square by dt square of I of t plus 1 by c d by dt. That is done here. Then differentiation of double differentiation of constants is 0. R is written as it is. So d square by dt square of I of t and so on. So wherever t is there, replace it by t0 plus r d square by dt square of I0 plus 1 by c r, right. So it is to be calculated here. It is to be calculated, so that move it to the right side. So minus 1 by c. So this r should be multiplied here. Right. So it is calculated already. Minus 100 divided by 1. C is 1 microfarad. R is 1k. So minus into minus, it is plus. 100 divided by 1 milli here. So can I write this as 10 to the power plus 5 amperes per second square. Is that okay? Here 2 plus 3, it is 5. d square by dt square of I0 plus equals to 10 to the power 5 amperes per second square. All of you got the same answer? Any different answers? Here 1 micro and 1k. 1 micro and 1k is what? 1 milli. So 1 milli, if it comes to the numerator, it is 10 to the power 3. 10 to the power 3 plus 10 to the power 2, it is 10 to the power 5. All of you got the same? It is a simple problem. So follow these steps. Once again, it will be repeated. Because of this capacitor uncharged, I have written Vc0 minus equals to Vc0 plus equals to 0 volt. You can write the reason in this case. And so I have written the operation of this switch K. When switch is operated, it is closed, then that is called as a T0 plus. Before switching, it was open, then that is called as a T0 minus. Alright, so this is what then equivalent circuit before switching. It is an equivalent circuit after switching. It is equivalent circuit before switching. It is equivalent circuit after switching. Before switching, the circuit was K was open and capacitor was uncharged. Immediately after switching, switch K is closed. Then this capacitor should be replaced by its equivalent circuit, that is short circuited. Then in this case, before switching, current was 0, so that I0 minus equals to 0 amperes because of switch was closed, open. Then immediately after switching, it is denoted as I0 plus, that can be calculated by Ohm's law, V by R. So that is what 0.1 amperes. Apply KVL to this equation, voltage VR plus VC. So that this VR can be written as I into R plus, using this formula, IC is equals to C into dV by dt. Then we can get the value of V by integrating on both sides. Integrating on both sides, we will get VC equals to 1 by C into IC. That value is substituted here. So already the first value I is calculated. Then our thing is to calculate di by dt, so that we don't find any differentiation of I term here. So that differentiate equation number 1, we will get a differentiation of I. We have done. So differentiation of constant is 0. Alright. So in this equation, replace T by 0 plus. Alright. So we know I of 0 plus, that is calculated 0.1. Simplify, we will get minus 100 amperes per second. Then they have asked us to calculate a d square by dt square. So that differentiate equation number 2 once again. We will get differentiation of this. It is a constant, no issue. It is 0. Differentiation of this is d square by dt square. Differentiation of this is 1 by c into d by dt. Alright, that is done here. Then substitute this value as a 0. Then replace t by 0 plus, and we have calculated d by dt of I0 plus, that as a minus 100. Do simplify, we will get double differentiation of the current immediately after switching is 10 to the power 5 amperes per second square. So you should be very careful regarding the units. Obviously it is current, but it is double differentiation, so that it is divided by second square. Alright, then we will solve the next problem. Let me know, have you understood? Let me know, have you understood the previous problem? Alright, we go ahead then. So read the problem properly. In the circuit shown in the figure, switch K is closed at t is equals to 0 with 0 current in the conductor or an inductor. So find the value of I, di by dt, and d square I by dt square at t is equals to 0 plus. For the element values, V equals to 100, R equals to 10, L equals to 1. Alright. So because of this, 0 current in the conductor. That means what? IL 0 minus, that is equals to 0 amperes. Can I write this as IL 0 plus? Because current through an inductor changes not instantaneously. So that in a conductor, before and after switching, current through an inductor will be same. Because of this, I can written here. And you can write the status of the switch. In T0 minus, switch was open. in a T0 plus, switch will be closed. Alright, and it is what the equivalent circuit before switching R, L, it is V, and it is status of K. It is what equivalent circuit before switching. Then after switching, switch is closed, resistor, then inductor should be represented by open circuit. I have used this concept here. See here, inductor is there. Before switching, zero current is flowing through it. Then after switching, it should be replaced by open circuit. So before switching, zero current was flowing. Immediately after switching, it should be replaced by open circuit. So that immediately after switching, it is replaced by open circuit. It is resistor R. Alright. Now apply KVL to given circuit. So that what is that? Voltage V equals to voltage across resistor plus voltage across inductor. Now we know that voltage across inductor equals to IL into d by dt of, it is what? L into dL by dt. L into current through an inductor, differentiation of current through an inductor. Alright. Now this V equals to I of t into R plus VL is what? VL is what? L into d by dt of I of t. Call this as equation number 1. Already we have calculated this first thing. What is that? It is 0 amperes. That is already calculated as 0 amperes. Now need to calculate the first differentiation of the current at t is equals to 0 plus. First differentiation of the current at t is equals to, now substitute the values, substitute the values before substituting, replace t by 0 plus. What will get? I of 0 plus into R plus L into d by dt of 0 plus. What is voltage? Here we don't have any differentiation here. Here we don't have any differentiation, so that direct value should be written here. What is V? V is given as 100. That is equals to, what is I0 plus? That is 0 into R plus value of L is 1 into d by dt of I0 plus. So it is 0. Then what is the value of first differentiation of I0 plus? That is equals to 100 amperes per second. Alright, next it is calculated now. Next thing is to calculate d square by dt square of I at 0 plus. Then differentiate equation number 1. Differentiate equation number 1, what will get? D by dt of V, that is equals to d by dt of I of t into R plus L into d by dt of d square by dt square of I of t. Now replace t by 0 plus. Then it is differentiation of the constant. Now it is 0. That is equals to d by dt of I of 0 plus into R L into d square by dt square of I0 plus. So we have calculated this value. This value is 100. 100 into resistor value is 10. So it is 1000 if it comes there. D square by dt square of I of 0 plus equals to L value is 1 itself. So that its value is minus 1000 amperes per second square. Is that right? So it is calculated. It is 100 into R is 10. It is 1000. If it comes there, it is minus 1000. So divided by L is 1. So that we will get d square by dt square of I of 0 plus equals to minus 1000 amperes per second square. It is also calculated here. Can you reply? Have you understood this problem? Alright, good. We do see the next problem. Okay. Here, in previous problems, we discussed only only inductor and only capacitor. RL circuit and RC circuits were discussed. In this case, RLC circuits are discussed. So, in the circuit shown in the figure, voltage V is equals to 10, R is equals to 10 ohm, L equals to 1 Henry, C is equals to 10 microseconds, and they have given Vc 0 equals to 0. Find I0 plus d by dt of 0 plus d square by dt of 0 plus. Alright. So they have given one condition here. What is that? Vc 0 plus equals to 0. The meaning of this is capacitor is uncharged previously. So capacitor is uncharged previously means Vc 0 minus equals to Vc 0 plus equals to 0 volt. This is the first conclusion we do get from the given data. And nature of K at 0 minus it was open, at t0 plus it will be closed. Okay. Then what is the equivalent circuit before switching? Before switching, the switch was switch was open. It is a resistor, it is an inductor, it is a capacitor. Then what is this current? This current is I. Is that the current flowing through an inductor? Yeah. Then we don't find any closed circuit here. Obviously the current before switching, it is equals to 0. Is that the same current flowing through an inductor? Yeah. So that is equals to immediately after switching. It is the property of an inductor. I repeat, it is the equivalent circuit before switching. Before switching, the K was open. If K was open, current flowing through this circuit, current flowing in this circuit is 0 because this source is not connected to these passive elements. And is that the same current flowing through an inductor? Yes, this is the same current. It is the before switching. Then we know the property of an inductor. Immediately before and after switching, current through an inductor is same. If it is 0 amperes, then after switching it will carry the same current. Alright, so you can see here we know the equivalent circuits, we know the properties of the capacitor and the inductor. Then let us draw equivalent circuit immediately after switching. Immediately after switching, the status of the K is closed. Alright, so resistor should be written as it is. Alright, so what about inductor? Inductor is carrying 0 current. That should be replaced by open circuit. And capacitor is carrying 0 volt. That should be replaced by the short circuit. It is what? Equivalent circuit immediately after switching. I have used this concept. The first concept was this one. Initially, inductor was carrying 0 current and it was replaced by open circuit. Then capacitor initially uncharged and it is replaced by short circuit. These two concepts are used and written the equivalent circuit at t is equals to 0 plus. Alright? Okay. Now, apply KVL to given circuit. What is that? V equals to voltage across resistor plus voltage across inductor plus voltage across capacitor. That is equals to, what is this voltage across resistor? I of t into R plus, what is voltage across inductor? L into d by dt of I of t plus, what is voltage across capacitor? 1 by C into integration of I of t. Is that okay? Is that okay? Means I have used here VL equals to L into d by dt of I. Then VC equals to, one more equation. One more equation is current through capacitor equals to C into dV by dt. And these two equations are used and substituted in the equation. For simplicity, call this as equation number 1. And wherever t is there, replace it by t0 plus. V equals to I0 plus into R plus L into d by dt of I0 plus 1 by C into I0 plus. Alright? We know that it is nothing but, this is nothing but VC0 plus. Is that okay? So this complete term is nothing but, is that capacitor voltage? Is that the capacitor voltage? Then can I write this as VC0 plus? Alright. It is needed. What is the value of V? The value of V is 10. What is I0 plus? That is calculated already. That is equals to 0 into R plus L into d by dt of I0 plus. That is equals to, it is already calculated, VC0 plus, it is also 0. Now, therefore, d by dt of I0 plus equals to, is that value of L is what? 1? Is that only 10 amperes per second? Do you have any doubt till now? Do you have any doubt till now? Can you reply quickly? I need 2 to 3 minutes more to complete this problem. Can you reply? Do you have any doubt till now? When? Due to inductor, it will be open circuit. Alright. So this is what equivalent circuit immediately after switching. And we have applied KVL to the given circuit. But okay, so you can write equivalent circuit at a t is equals to some time interval, say 1 second, 2 seconds. After immediately switching, what happens there? Can I replace this by inductor? Can I replace it by a resistor, inductor and capacitor? This is what the circuit. So we have applied KVL for this circuit by assuming K is closed after some time interval. Is that okay? That's why I have given, we are applying the KVL to the given circuit after closing. Once the switch is closed, this is the equivalent circuit, and for this we have applied the a KVL. Okay, so your question is inductor is open, I is 0, that is applied here, no? Wherever I is there, that is replaced by 0. It doesn't mean that first differentiation is 0. There is a difference. It is only I, it is first differentiation of I. They are not one and the same. According to you, because of this open circuit, I is replaced by 0. But that is not equals to d by dt of first differentiation of its value. First differentiation and normal values are different. That's why we will get first differentiation of I of 0 is 10 amperes. You should not differentiate this I directly, d by dt of I equals to 0. That is wrong. If this equation is differentiated, d by dt of I0 plus, that gives 0 value, but that is not correct value. We do get that value by applying KVL to the complete circuit, by substituting all the values, and after simplification we will get 10 amperes. Am I okay? Alright, good. So it is calculated now. It is calculated. Next, what to do to calculate the double differentiation of the I term? Let us differentiate equation number once again. Let us differentiate equation number once again. What will get? Okay. Differentiate equation number 1. So differentiation of V is what? D by dt of V, that is equals to d by dt of I of t into R plus L into t square by dt square of I of t plus 1 by C is as it is. Differentiation and integration, they do cancel each other. Now we will get I of t. Alright. Now what is this value? Differentiation of constant. Differentiation of constant, that is 0, because 10, differentiation of 10 is 0. Now replace wherever you do find t by a 0 plus. D by dt of I of 0 plus into R plus L into d square by dt square of I of 0 plus 1 by C into I of 0 plus. 0 equals to, is that calculated? D by dt of I0 plus, it is 10. What is R value? R value is again 10 plus L value is 1, d square by dt square of I0 plus. What is I0 plus? I0 plus is this equals to 0? I0 plus, is that 0? Is that 0? 0 divided by C. Then what will get? Do simplify. T square by dt square of I0 plus equals to minus 100 amperes per second square. Is that okay? Is that okay? So it is one of the important problem as the examination point of view. All right. So I don't forget to write the units. And this video will be uploaded in the YouTube channel and link will be provided. To show the second problem, sir, so that we can take a screenshot. Rohit, the same videos will be uploaded in the YouTube channel. Link will be provided. Even though you can take the screenshot, no issue. It is second. All right. So anyhow, this video will be uploaded in the YouTube channel and link will be provided by evening. Alright, so quickly tell me your attendance.